All right, so we're going to do just a tiny bit of Chapter 8. I know we've done a bit of Chapter 6, 7, and 8. This has been a big unit. Heads up, your test on these parts of Chapters 6, 7, and 8 will be next week. You'll see a Zoom link posted. You're going to, again, have Thursday and Friday be quiz time. If you're not taking the MCAs, that's a great time to tackle some missing assignments. So I'll have a reminder in Google Classroom with to maybe spend that Thursday if you're not working on the MCAs, focused on those missing assignments. And then you will have the Zoom link to schedule for the test, and the test will be next week on May 6th and May 7th. So, knowing that, let's get ourselves ready for notes on vectors. So, get yourself pencil and paper, and we're going to get started. Now, a vector is just a mathematical object, just like a function is a mathematical object, a variable is a mathematical object. What makes vector special is that it's an object with magnitude, and what that means is it has a size. If you're talking about maybe a physics problem, that might mean a length or a strength, because we also use vectors for force, like gravity. It has magnitude and direction. So the way that we often write vectors, this would be a vector, a picture of a vector. We draw it as an arrow. And in this case, right, its magnitude is this length and its direction is about maybe 30 degrees. And the way that we would write that is in terms of its horizontal and then vertical components, almost like rise and run. So you can write it in two ways. If this has a length x and this has a length y, you could write the vector as, it's a parenthesis, but it's pointed on the end. So you could write it as xy like that. Or you could write it as x and then I, and that I is usually really bold, plus y, and then j, you could really bold like that. You can also have, so these are like the parentheses I'm trying to draw here, just so you can see that. All right. So, number 1, write the vector from the initial point -1, 3 to the terminal point q, -6. So this is our initial point where it begins, and then the arrow here is our terminal point. So if I'm thinking about this graphically, because these are ordered pairs on the coordinate plane, -1, 3 is our start, and -6, -1, q, and our vector goes in between like so. Now our horizontal component, x, and our vertical component, y, as I've said before, can be just expressed as our slope. So the x is x2 minus x1. The vertical component, y2 minus y1. So in this case, we've got -6 minus -1 and -1, not a comma, minus 3. So -6, this becomes -6 plus 1. So -5, which would make sense based on this drawing. Our horizontal component is going negative this way, 5 spaces. And our vertical component is going down -4. So again, you can think about it just like slope. Now, addition with vectors is one of those things where it's kind of nice because it works out exactly the way we feel like it should. So if I have two vectors, like here, u is 2, -3, and v is -1, 2. If I want to add them together, I add their component parts. So if I say, oh, what are the vectors u plus v? Well, then it's the x value from u plus the x value from v, the y value from u plus the y value from v. Now, u and v are just normal vector variables. I know they look identical. I will try my best to make them look different. It's just what most people use as their variables for vectors, just like we use theta and x for a lot of our variables. So here we have 2 plus -1 for our horizontal components, and -3 plus 2 for our vertical components. So that would simplify to 1, -1. That's what I mean. Addition works exactly the way you feel like it should. So does scalar multiplication. Scalar multiplication is the idea is that if this is my vector, let's just say it's u. If I want to have the vector 5u, it's just u 5 times longer. And so all you need to do is that if I want to do some k times u, it's k times the the horizontal component and k times the vertical component. So in this case, 2u minus v, order of operations still applies to vectors, so we want to do our multiplication first. So we'll start with 2u, which is equal to 2 times 2, 2 times -3, just multiplying our components by 2. So we end up with 4, -6, and then we're subtracting, and if this is how addition works, subtraction works exactly the way you think it should. So 2u minus v is equal to 2u, which is 4, minus -1 from v, and then -6 minus 2 from v. Right, these are our v terms. These are our 2u. And then we evaluate. So 4 plus 1 is 5. -6 minus 2 is -8. So there's addition. We saw some subtraction. We've seen scalar multiplication. Now, the other thing we want to be able to find are the magnitude and direction of vectors. So the magnitude, as you remember, is just the length of the vector, and we write it as like the absolute value signs. So if you think about, again, the vector u, it's got the horizontal component and the vertical component. So you'll notice that its length forms the hypotenuse of a right triangle. So you can say that u squared is equal to x squared plus y squared. So what you'll often see as the formula for magnitude is the square root of the horizontal component squared plus the vertical component squared. So here, if it says find the magnitude of u, which again, 2, -3, you can just use that formula. So the magnitude of u, which again we write with absolute value signs, is equal to root 2 squared plus -3 squared, which is root 4 plus 9, which equals root 13. Now, given a new vector v, where magnitude of v is 4, and the angle, the direction, is pi over 3, so that's one thing that's always helpful to remember. We're still thinking about our unit circle here. One thing that's nice is you can think, oh, well, if this is my vector u, we've got our horizontal, we've got our vertical, so the angle, just like the unit circle, can be found. So this is the direction. In this case, it's given to us, but it can also be found using the component forms, right? Same thing, x and y are, not sine, cosine and sine. And what I often will see recommend students can do is that the tangent of theta, you put y over x, and then this will usually give you a nice equation versus trying to back solve unless they're nice on the unit circle values. In this case, this is a nice on the unit circle value. Pi over 3 is one of the ones that we know. So if I'm looking at my regular unit circle, the magnitude of u would be 1, and the directions would be just like its ordered pair, 1/2 and root 3 over 2 for horizontal and vertical. Now, this is a u. If v is 4, then I can say, since it's the unit circle, u is equal to 1, then v is equal to 4. These two ideas together imply that v is equal to 4 times u, which we can use our coordinate point, 4 times 1/2, and 4 times root 3 over 2. Simplifies, the component of v is 2 and 2 root 3. Whoops, sorry about that. So here's a good introduction on vectors. We are going to have one more vector idea in our next lesson, but please let me know if you're stuck or confused about anything that we've done so far.